Hi everyone, today we're going to talk about ionic, covalent, and metallic bonds. And keep in mind that positive attracts to negative in chemistry, so the positively charged elements attract to negatively charged elements. Now, going in the order that we have, ionic bonds. So Wikipedia defines an ionic bond. Bonding is a type of chemical bond that involves the electrostatic attraction between oppositely charged ions, so positive, negative, and is the primary interaction occurring in ionic compounds. So you see here we have sodium chloride, which is the salt, typical ionic compound. So again, that's an atom that wants to give an electron here, and here's an atom that wants to take an electron, because you see in the outer shell we have this extra electron, and for chloride the outer shell lacks an electron to have to have it fully closed, to have 8 of electrons on the outer shell. 8, right? 1, 2, 3, 4, 5. Yes, just counting. Now, so elements themselves want to be like noble gases, which again has the closed orbital. And we're going, just for one moment, let's look at the periodic table, which is something that we'll be using all the time. We see that the best elements that want to give off electrons are alkali metals. Sorry. So here they are in red. And the halogens, now they want to take electrons. So halogens are located, as you see, in there. These guys, because they have a higher electronegativity. So going back to what we have, sodium and chloride. So we have a cation here, positively charged, plus an anion, negatively charged, which gives us an ionic bond. So again, negative and positive will stick together and give us an ionic bond. So again, that's where one atom wants to share an electron, another one wants to take an electron. And that's the way they bond together, and both of them become more or less stable. Now, again, yes, sodium chloride. This is a salt. I really like this picture. Nice. Now, covalent bonds, moving forward. Wikipedia again defines a covalent bond, also called a molecular bond, as a chemical bond that involves the sharing of electron pairs between atoms. Very common. And these electron pairs are known as shared pairs or bonding pairs. So they are usually, so here we have an oxygen gas, also used often, usually an example is also a hydrogen gas, but here you have 1, 2, 3, 4, 5, 6 electrons in the outer shell, and 6 because it's the same element, but they want to be more stable, right? If suppose there are only oxygen in there, and they want to have 8, this illusion of 8 electrons in the outer shell. So what did they do? They combine, they just stick together, and even though, this might look a little complex, but even though theoretically they still have only 6 of their electrons, they share each other's electrons too, and they have this bond in here, which is sort of I'd say an illusion of having 8 electrons, but they pair together. Same happens with hydrogen. So say you can pick any and combine together, pretty much theoretically. Now, I really like this one too. And also, there is covalent bond, polar covalent bond, water molecule. Pretty much similar principle. Oxygen wants to be more stable, hydrogen wants to be more stable, especially oxygen. And just one side is more negative, another is more positive, which makes compound polar. Now, moving forward, metallic bonding. Now, metallic bonding, as Wikipedia defines it, is a type of chemical bonding that arises from the electrostatic attractive force between conduction electrons in the form of an electron cloud of delocalized electrons and positively charged metal ions. So here it's easier explanation. In this type of bonding, electrons can easily move from atom to atom, hence it will conduct electricity. So in this case, I used iron. So those guys are happy to share electrons. If you look at the periodic table here, they're happy to share electrons, and they become positively charged, and they themselves they are attracted to the electrons they share. So this is also a reason why metals such as iron are flexible and malleable. Now, last thing, conclusion. What is the difference between the bonds? Difference between the ionic, covalent, and metallic bonds. So this shot here, I think this is just a perfection for definition viewers. Ionic bonds, they share covalent bonds, ionic bonds, vice versa, they give, take. Covalent bonds share. Metallic bonds, they will just, bounce them back and forth pretty much, the electrons. So ions here are attract each other through electrostatic forces of attraction as they are oppositely charged, so plus and minus. Now, covalent bonding occurs when the atoms, molecules share pairs of electrons here, as you see. And metallic bonding occurs in metals and leads to the structures of metal atoms arranged in a regular pattern, which is also pretty easy. So that would be it. Thank you. I really like this one. My name is Bond, Ionic Bond, taken, not shared. Awesome. Thanks for everyone who has contributed to making such great pictures. Yeah. And here are some resources I've used, pretty much only Wikipedia. And again, I am creating these videos based on the Khan Academy course on core biology. Thank you.